students. Today we'll complete part 6 of solid state class 12 science chemistry. Here today we'll understand how to find the formula of compound from its packing. Some important point to remember are as follows. Particles are closely packed in CCP and HCP structures. CCP structure is the cubic close packing structure in 3D and HCP is the hexagonal close packing structure in 3 dimension. And particle means here we are referring atoms, molecules or ions. So this is your first point. Second point to remember is in 3D structure there are two type of void present. Void is the empty space that is left vacant in the 3-dimensional packing of solids. Now there are two types of voids. One is octahedral void. These are bigger in size, and another one is tetrahedral void, which is smaller than that of octahedral void. You have to remember one more thing, that in octahedral void the empty space formed between 6 particles, and in tetrahedral void it is captured between 4 particles. Next important point is number of octahedral void in the close packing is equal to the number of particles present in the packing. If we consider the number of particles to be n, then number of octahedral void will be equal to n, and that of number of tetrahedral void will be twice n. Next, beaker ion. Now beaker ions are generally anion if we are considering ionic solid. So beaker ion or the anion will always occupy the lattice site, and the smaller ion, and if it is a ionic compound we will be referring the cations because it is always smaller in size, they will occupy the voids in the packing. All the voids are not filled. It is not necessary that every time the voids will be occupied by particle. Sometime it may happen that it is fully occupied by particle, but sometime it is also possible that the voids are partially filled with any of the particles. So these are some important points we have to remember when we'll consider the packing to find its formula. Next, the hexagonal close packed or HCP has a coordination number of 12 and it contains 6 atoms. So if you have to solve a problem where HCP you have to consider, then you have to remember that the number of atom it will show or it have is 6 and its coordination number is 12. Coordination number means the neighboring atom present. Next, in FCC, that is in face-centered cubic cell, the coordination number is 12, but it contains 4 atoms. In FCC, we have already calculated the number of atoms, and we know that there are 4 atoms per unit cell. Next, in BCC or in body-centered cubic cell, the coordination number is 8 and it contains 2 atoms. So, 4 atoms in FCC and 2 atoms in BCC we have already calculated. Now let's have a glance about 6 atoms in hexagonal close packed structure. So here you see hexagonal close packed structure is the basic unit, one of the basic unit cell. Here 12 corner atoms. Okay, in hexagon you are getting 12 corner and each corner atom contribute 1/6. So 12 into 1 by 6, we are getting 2 atoms. Then 2 atoms are present at the face that contribute half. You know that what the atom present in the face, they contribute half. So 2 into half is equal to 1. And there are 3 center atoms that are not being distributed by anything. So it will be 3 center atoms into 1 equal to 3. So if you sum up, the value is coming out as 6. Thus, in hexagonal close pack, total number of atom per unit cell is equal to 6. Now we'll solve one numeral. The first numeral is, in a compound, B ions form a close pack structure. That means they are talking about CCP structure. And here A ions occupy all the tetrahedral void. That means B ion is an anion and A ion is a cation that is occupying the void, tetrahedral void. What is the formula of the compound? So here we'll consider the number of particles that is forming the lattice. B is equal to 100. Instead of 100, you can consider any number. You can also consider it to be x. That way also you can solve. So we'll consider any number for B. Let it be 100. Therefore, the number of A ions will be number of tetrahedral void, because they say that all the tetrahedral voids are filled with A. So number of A ions will be the number of tetrahedral void present. Now, the number of tetrahedral void present in the close pack structure is double than that of the particles. So the value will be twice of that of B. The same given here, 2 into number of B. Number of B we consider 100. So number of A ions will be 2 into 100, that is 200. So what is the ratio coming? Cation is to anion ratio is coming as 200 is to 100, that is 2 is to 1. So here from, if you are trying to derive the formula, your formula is coming as A to B. So the compound is having the formula A to B. Next, a cubic solid is made of two elements, P and Q. Atoms of Q are at the corners of the cube and P at the body center. What is the formula of the compound? What are the coordination number of P and Q? Okay, here you have also need to answer about the coordination number. So check here. Here it is given that the atoms of Q are present at the corner of the cube. Now cube have how many corners? We know that cube have 8 corners, right? Therefore the number of Q in one unit cell is 8, and the corner atom always they contribute 1 by 8. So it will be 8 into 1 by 8 equal to 1, right? It is also given that the atoms P are present at the body center. Now if any atom is present at the body center, they contribute 1 because they do not have any share with the other unit cell. So number of atoms P in one unit cell is equal to 1. So we got the value of Q. We know how many P are there. This means that the ratio of the number of P atoms to the number of Q atoms, that is P is to Q, is 1 is to 1. So the formula is PQ. Okay. Now they are talking about BCC. Okay. This what is the coordination number in BCC? We already know that if it is a BCC structure, the coordination number is 8 and total number of atoms present in BCC was 2. So coordination number in case of P and Q will be 8. So here is the answer. One more. Here they had given in crystalline solid, anions C are arranged in cubic close packing structure. They are talking about CCP structure. Cations A occupy 50% of the tetrahedral voids and cation B occupy 50% of the octahedral voids. What is the formula of the solid? You have to find the formula of the solid. We'll consider number of anions C equal to 100 or X, anything of your choice. Let it be 100 here. Suppose number of cation is A. They have said A is how much? A is 50% of tetrahedral void. So A is equal to 50%, that means 50 by 100 into number of tetrahedral void. Now number of tetrahedral void is always twice that of the number of atoms present in the lattice, and lattice is always occupied by anions. So it is coming out as 50 by 100 is equal to half, half into 2 into C. Next, number of cation B occupy 50% of octahedral void. So B is equal to 50 by 100 into number of octahedral void. Number of octahedral void is the number of particles. So it is equal to half into C, that is half into 100 is equal to 50. So here half into 2 into C, that means equal to C. So the value will be 100 for A atom. So A you are getting 100, B you got 50, and for C you already consider it to be 100. So the ratio is coming out as 2:1:2, and hence the formula of the compound will be A2BC2. Okay, hope it is clear to you. Like that, some more problem you will solve from your exercise given in chapter 1. That much for today. Thank you.